Students, I'm now going to the second part where we said we need to look at how we calculate the normal force, especially on this case. Remember, I said we are attempting question 2. So the first step in question 2 is to draw a free body diagram. So I'm going to look at my 3 kg and my 1.5 kg. I hope you have tried to draw those free body diagrams. You can pause the video and draw them. Then let's look at what we expected to know. This for 3 kg, this is our free body diagram. This is the normal force. This is the frictional force. Remember, friction opposes motion. Then here is the second diagram for 1.5 kg. So this is our 25 newtons force. You can put it like this also, as long it is in the same line and in the same direction. Your forces must have arrows. So these are our free body diagrams. These are our free body diagrams. Now we want to look at how we can calculate the normal force on 3 kg. How many forces are acting on 3 kg? So we have got 1, 2, 3, 4 forces. So when we're calculating the normal force, let's look at the direction of the normal force. The normal force is a vertical force. So we need to write the expression of net force in the vertical direction. So how many forces are acting in the vertical direction? There is the normal force, there is mg. So remember, F net is equals to ma, so that is the first part. Then ma is equals to the normal force, which is going upwards, then plus minus fg, which is our mg. Then there is no acceleration upwards or downwards on this body, so we're going to say ma is equals to a is equals to 0. Then we express this one 3 times 9.8, which is mg, which is our fg. Then we find the normal force. So no stress there on how to find the normal force on 3 kg, because there is no force with components. So this is the normal force on 3 kg. So you can go through this working. So this is our normal force. So where are we going to use our normal force? We're going to use it to calculate the frictional force. But I want us to quickly shift our attention on this body, where we have a force like this, which has got some components. The first thing when we're calculating the normal force is to resolve our force. We need to resolve that force, because this force has got a component which is going downwards. It has got this component which is going downwards. So the component that goes downwards, given an angle there, is our 25 sine theta. So we need to resolve that force. How do we resolve that force? So here is how we can resolve the force. We need to resolve the 25 newtons force. So we've got this component. So it's like you are reaching this point. You can go through this way and that way. So there is this way. If we go this way, so that we form a right angle triangle on that force, we can draw a right angle triangle on that force like this. So if we're going this way, this side is opposite, so it's 25 sine. So this is our vertical component. This is our horizontal component. Now, once we have the components, we can calculate the normal force on this body. We use the same expression as we did on the first diagram. F net is equals to ma. But in this case, our ma is equals to the normal force, which is going upwards, plus minus mg, which is going downwards, plus minus the vertical component. So the vertical component is also part of the vertical forces. So this is 25 sine theta. So we go on and say our normal force, ma, there is no movement up and down. So ma is equals to normal force minus 1.5 times 9.8, which is mg, minus 25 sine theta. So please note, when we're calculating the normal force, when we have a force like this with components, we also need to include a component of that force. So in this way, this force is going down, so the vertical component also faces down. In other questions, it can be going up, so the vertical component will be facing up. So on the direction, you can see now, this is negative, negative. It shows that this is going down, this one is also going down. So always include a component when you are calculating the normal force, when there is a force with components on that vertical diagram. So this is how we go on and go on. So these are ways to resolve. So we can resolve our forces in this way and this way. We can also draw another triangle like this, going this way first and then that way first. And then we can use that 30 degrees there. So this is for the second diagram. But the easiest way is this one on how to resolve, so that you get your component. So this is how we get the normal force. If a body has got a force which has got some components. Remember this. Can you go through this working on how to get the normal force? In the next video, I'm going to go on with questions now and how we are using our normal force to calculate the frictional force. Thank you very much. Thank you.